All right, so we know hydrogen's 2.1. What's phosphorus though? 2.1, okay. And then oxygen? All right. Now, when you see oxygen, when you see nitrogen, when you see fluorine, if you kind of look in the periodic table, they're kind of in that group over there, nitrogen, oxygen, fluorine, chlorine, that area. You think probably going to be polar, okay? Because they're high with electronegativity, all right? Especially if you have something like this. Now let's check it out. Hydrogen and phosphorus, the difference is 0, right? So if those were the only things, it would be a non-polar molecule. The problem is we have this phosphorus oxygen and then a hydrogen oxygen over here. So we need to check that out. It's going to go towards the oxygen because it's higher. What's the difference between these two? 1.4, and the same thing here, 1.4, right? So that region is going to be pulling electrons towards it. Now, is it pulling enough for it to be polar? Yeah, it's between 0.4 and 1.9, right? So it's going to be polar in there, all right? These ones are just kind of hanging out, but everything's getting kind of pulled over here. So what's the charge of the oxygen going to be? Slightly, yeah, it's going to be slightly negative. And then, again, kind of like looking at this, can you kind of draw a line to slice this molecule in half and look at charges on each side? It's hard to do, but the idea would be, whoops, something like if you cut through these two bonds right here, which again, it's not great, that side of it would be negative, and then this side would all be positive, all right? So then that's where you put your positive, somewhere over here. You need to put a couple of them so that they're over here. So all of this side would be positive, slightly positive, and that side would be slightly negative.